Hi everyone, in this video we are going to look at the preferential discharge of different species at the different electrodes, in particular the anode and the cathode. So this is an electrolytic cell which is very different from a voltaic cell which has spontaneous reactions, and in a voltaic cell the anode and cathode is determined by the reaction itself. The one that gets oxidized will give you the electron, so it is anode, and the ones that get reduced will give you the cathode. But in an electrolytic cell, the one that drives the reaction is this battery here. So we usually start our discussion from the battery. So the shorter side will be our negative terminal, the longer side will be our positive terminal, and because it is connected here, this will be our positive terminal, this will be our negative terminal. So as we know, the positive terminal will attract the cations. Alright, anything that's positively charged, and the positive terminal will attract the anions, anything that's negatively charged. So just by looking at this, right, the next step that we need to do after this deciding which is the cathode and which is the anode and what are the charges, right, we need to decide the species that go to each electrode. So let's look at this solution. So in this solution we only have three things: Cu2 plus, SO4 2 minus, and water, right, which is all over the place, and it's predominantly water, not H plus or OH minus. So if we take a look at the electrodes, the negative charge will attract the positive cation. So at this electrode you have Cu2 plus, and because this solution is filled with water, you will have H2O around it. Right, likewise in the other electrode, because it's the anode, it will attract the anions, so you will get SO4 2 minus here, and you also get H2O around this electrode. So right now, after this step, we will want to compare their E0 values, alright, to see which is preferentially oxidized or reduced. So just by looking at this portion over here where we have the cathode, right, we will be able to see who gets reduced. So we have to pick out the two equations with Cu2 plus and H2O, right, and decide who gets reduced over here. So our electrode is Cu, okay, which cannot be reduced any further, so we don't really talk about that. Cu2 plus can be reduced and water can be reduced. So we have the equation for Cu2 plus and water here. Notice they are both on the left hand side of the equation. So if we compare the E0 values, we will see the more positive one will get reduced. Therefore, copper will be reduced from Cu2 plus to Cu. It's rather than water forming hydrogen gas. Okay. Whereas if we take a look at the anode, alright, we have SO4 2 minus and H2O and copper itself. Right, so copper can be oxidized to Cu2 plus, SO4 2 minus can be oxidized to our S2O8 2 minus, and water can be oxidized to O2. So notice all our reagents are on the right hand side of the equation. So what we want to do now is to compare between all three values, and we choose the least positive or the most negative value. In this case it is copper again. So what we'll observe at the anode is the oxidation of copper to Cu2 plus. So what you'll realize is that this is actually a classical question on the purification of copper, where our impure copper goes from the anode to the cathode. But of course, the main problem or the issue with this question, with this diagram, is that we usually include the anode on the left and the cathode on the right. In this case it is exactly the flip side of it, right? So this is how we can determine who gets preferentially discharged, and these are the steps that we need to take. And so to reiterate, we look at the battery first to determine where is the anode and where is the cathode. We determine who goes to which electrode. Neutral species cover both electrodes. Then we look at the relevant E0 values, right, to decide who gets oxidized and who gets reduced. Right, so that is how we can decide who is preferentially discharged. So next up, we will talk about how we can use this information to decide to answer calculation questions.